All right, everybody, and welcome to Chapter 5, which deals with analytic trigonometry. So we're going to begin by using trig identities, introducing them, right? We have already before, but we're going to get into it a little bit more. And we're going to write the fundamental trig identities, and we're going to use them to evaluate functions and simplify expressions and rewrite expressions. Okay, so let's begin. We know we know what trig the identities are. We're going to get into them more, and we're going to use them to evaluate functions, to simplify expressions, and then eventually to develop new identities, and finally to solve equations. But let's first dip our toe into the water here. Remember that the trig identities, what are they defined as? Okay, so there's different ones. So you have the reciprocal identities, which is basically saying like, hey, sine and cosecant are reciprocals of one another. Cosine and secant are reciprocals of one another, and tangent and cotangent are reciprocal of one another. And then we have the quotient identities, which means that tangent can be written as sine over cosine. Cotangent can be written as cosine over sine, and then the Pythagorean identities, and that comes from the Pythagorean theorem, right? Because you have sine squared plus cosine squared is equal to 1, and then from that one you can derive the next two, but if you don't want to do that, you can write on a piece of paper and have it next to you when you do your homework. That's totally cool. We have 1 plus tangent squared is equal to secant squared. 1 plus cotangent squared of u is equal to cosecant squared of u. So it would be really helpful if you wrote this down on a note card or had it somewhere so that you were just ready to go and you could use them as you want. So we have a few more. So cofunction. So we know sine, cosine, tangent, cotangent, secant, cosecant. So notice how those are like cofunctions. So what's the relationship? So if you take the sine of pi over 2 minus some angle, that's the same as cosine of that angle, and vice versa. So cosine of pi over 2 minus the angle is equal to the same value as sine of the angle. Okay, so this can be shown if you draw the graph and you move it pi over 2, you can see the difference. You can see what happens. So let's see what else. Let's see here. Tangent is the same. Tangent and cotangent are cofunction identities. So tangent of pi over 2 minus an angle is equal to cotangent, and the same thing goes for secant and cosecant. Okay. Now, even and odd. Remember, what's the definition of an odd function or an odd even? If you put in, or if you rewrite the function using negative x or negative u or what have you, and you get negative the original function, it's odd. And if you get the original function positive, then it's even. So sine is odd because sine of negative u is equal to the same as saying negative sine of u. Cosine would be considered even. Cosine of negative u is equal to cosine of u. Tangent, odd. Tangent of negative u is equal to negative tangent of u. So cosecant, odd. Secant is even, and then cotangent is odd. Okay, and then sometimes we use the Pythagorean identities and we express them in radical form like this. Sine of u is equal to plus or minus 1 minus cosine squared of u, or tangent of u is equal to plus or minus secant squared of u minus 1, where the sign depends on whatever, wherever u is, what's the choice of u. Okay, so let's see, how do we use these identities? Okay, so one common application is to use a value of trig functions to evaluate other trig functions. So let's suppose we're given this. We have secant of u is equal to negative 3/2, and tangent of u is positive, to find all the values of all 6 trig functions. Okay, so we know that cosine is the same as, it's the reciprocal of secant. So cosine of u is going to be negative 2/3, right? Because they're reciprocal functions. So we use that identity and we get cosine. Now we can use this value of cosine and the Pythagorean identity to solve for sine, okay? Because you know that sine squared plus cosine squared is equal to 1. We subtract both sides by cosine, we get sine squared of u is equal to 1 minus cosine squared of u. And if we plug in negative 2/3 for cosine, we can simplify and get 5/9 is equal to sine squared. But we know to solve for sine, we need to take the square root of both sides. But which one do we use? Do we use the positive solution or the negative solution? Well, what are we given? We are given that secant is negative, yeah? And we're also given that tangent is positive. So the only way that these two exist is in quadrant 3. Because in quadrant 3, both y and x are negative, right? And so that would make these two both be fulfilled. Okay, so since sine of u is negative when u is in quadrant 3, we use a negative root. So we would get sine of u is equal to a negative square root of 5 over the square root of 9, which is 3. Okay, so now that we have sine, we have cosine. Remember, you can find all the other functions now, right? Because sine of u is negative root 5 over 3, cosecant is just the reciprocal of that, right? And if I simplify the reciprocal, I would get negative 3 root 5 over 5. Cosine of u is negative 2/3. So secant of u, which is the reciprocal of cosine, is just going to be negative 3 over 2. That was given. Tangent of u is just sine over cosine. So we just write them as a ratio. The 3's cancel out, and you get root 5 over 2. And then cotangent is just the reciprocal of tangent. So that's 2 over root 5, but when I simplify this, I rationalize the denominator, I get 2 root 5 over 5. Okay, so finally, one way that we can do is also simplifying a trig expression. So let's say you're given sine of x cosine squared of x minus sine of x, and they ask to simplify this. Well, you would factor out you would look at and see what can I factor out. What identity can I use? How can I make this smaller and more simple? So you notice that sine is a common factor in this expression here, right? So if I factor out sine of x, I'm left with cosine squared of x minus 1. Now cosine squared of x minus 1 is very close to sine of x. But if I factor out a negative 1, I know that I have it here. Negative sine of x is equal to 1 minus cosine squared of x. But what is 1 minus cosine squared of x? Well, that's just sine squared of x, okay? So sine squared of x times negative sine of x will give me negative sine cubed of x. Okay, so that is that for that. Okay, so let's do another example. Let's rewrite 1 over 1 plus sine of x so that it's not in fractional form. Okay, so if I take this and one trick to remember is that the Pythagorean identity cosine squared of x is equal to 1 minus sine squared of x. That's a difference of squares, yeah? So if I was to factor 1 minus sine squared of x, that's 1 minus sine of x, 1 plus sine of x. So if I look here, I think to myself, wow, maybe if I multiply top and bottom by 1 minus sine of x, I could simplify the denominator, okay, so that I have just one term instead of two terms. So let's do that. So 1 over 1 plus sine of x can be rewritten as 1 over 1 plus sine of x times 1 minus sine of x on the top and 1 minus sine of x on the bottom. So then on the bottom, by difference of squares, you get 1 minus sine squared of x, and on the top, you get 1 minus sine of x. And then that's the Pythagorean identity. 1 minus sine squared of x becomes cosine squared of x, which is what we wanted. Now that cosine squared of x, we can split this fraction into 2. We get 1 over cosine squared of x minus sine of x over cosine squared of x. And 1 over cosine squared of x is easy enough to simplify. But let's hone in on this sine of x over cosine squared of x. I can rewrite this fraction as a product. What does that mean? So instead of cosine squared of x, if I write this cosine times cosine, and instead of sine of x, I write sine of x times 1, see how I get this third line right here? I get 1 over cosine squared of x minus sine of x over cosine x times 1 over cosine x. I basically just rewrote it in a different way because now in this form, these are all equal to other trig functions that are not fractions. So 1 over cosine squared of x is just secant squared of x because they're related, the reciprocal function, right? Sine of x over cosine of x is equal to tangent. And 1 over cosine x is secant by definition. So your final answer will be secant squared of x minus tangent of x times secant of x. Okay. So there's not that many homework problems to practice, but I would like you to practice this a little bit. So yeah, this is your super fun homework, and please bring all questions to class, and I will see you guys on the next video.